Imagine a grand symphony conducted by an endless number of planets, stars, and moons, each of which contributes to the performance in perfect harmony. However, there is a specific section of this cosmic symphony that has captured the attention of astronomers for an extended period: exoplanets. These are planets that exist outside of our solar system, hidden somewhere within the vast expanse of the Milky Way. It might surprise you to learn that, amid the countless celestial bodies, there are exoplanets strikingly similar to Earth, so remarkably similar that they could be considered the cosmic counterparts of our planet. Allow us to enter the world of Proxima B, an intriguing realm located just 4.2 light-years away. The James Webb Space Telescope is playing a key role in our quest to unravel these cosmic mysteries. Now imagine yourself traversing the enormous Milky Way galaxy, home to over a quadrillion exoplanets, a number that includes 15 zeros. To put that into perspective, if the size of these exoplanets were comparable to grains of sand, they wouldn't just fill the Grand Canyon, they would extend far beyond it, creating a second monumental geological feature on Earth, a Grand Canyon 2.0, sprawling for unimaginable distances. Surprisingly, roughly 20% of these enormous objects have been referred to as Earth-like in terms of their geography and climate conditions. This means there's a 1 in 5 chance of finding a twin of our planet. And that's not all. Surrounding these planets might also be quadrillions of moons, rocky satellites locked in a gravitational dance with their parent planets. Contemplating the possibility of discovering another celestial body that could host life, or might one day do so, is a thrilling prospect. The universe is full of possibilities. Now that we've laid it out, let's introduce the ultimate instrument for locating the intricacies of this cosmic scale, the James Webb Space Telescope. This cosmic detective, equipped with an enlarged main mirror composed of flexible segments, surpasses even the most cutting-edge optical instruments available. This is no ordinary lens. It's 6.5 meters in diameter, nearly 2.7% larger than the Hubble Space Telescope's mirror. Imagine the finest details it can capture, even from the tiniest hint of movement from a distant star billions of light-years away, and then analyze the surrounding planets. What makes the James Webb Space Telescope truly groundbreaking is not only its recognizing power but also its advanced technology, including state-of-the-art sensors and spectrographs. These instruments can do far more than just observe. They can analyze and process the light emitted or reflected by these vast celestial bodies, allowing scientists to decode their atmospheric composition, chemical balance, density, and even mass. Acting as a space-based scientist, the telescope can determine whether a planet contains organic compounds, water, or even oxygen. The capabilities of the James Webb Space Telescope have elevated it from a simple observer to a scientific genius. It's not just an upgrade over Hubble, it represents a leap forward in our understanding of the universe. If you were amazed by Hubble's discoveries, prepare for a truly extraordinary era of revelations as we broaden our comprehension of the universe. We must focus on one particular star in this celestial narrative, Proxima B. Since its discovery in 2016, this enigmatic planet has fascinated astronomers and astrobiologists alike, drawing comparisons to a play by Shakespeare, filled with intrigue and complexity. So what's the allure of Proxima B? First, it is extremely near our own galaxy, located just 4.2 light-years away from Earth. To put this in context, if we could travel at the speed of light, it would take just over 4 years to reach it. Roughly the same amount of time it takes for a TV series to become a cultural phenomenon. Now consider the significance of this proximity in the grand scheme of the universe, which spans over 93 billion light-years from end to end. Discovering a planet so near and so ripe for scientific investigation is like discovering a diamond in a mountain pile of rocks, a precious gem that could hold important secrets about life. Proxima itself has the potential to change everything we know about existence and habitability beyond Earth. Not only is it close, but tantalizing hints suggest it might be more than just similar. It could be Earth 2.0. Proxima B resides comfortably within the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Picture winding streams, cascading waterfalls, vast lakes, and possibly even oceans as deep and mysterious as the Mariana Trench. However, before we allow ourselves to fantasize about visiting Proxima B, we must consider a few characteristics that set this distant world apart. A single day on Proxima B lasts just 11 Earth days. Picture dawn that not only marks the beginning of a brand new day but progresses gradually, giving way to leisurely sunsets and afternoons that last for days, creating golden hours that photographers dream about. Even though this may sound idyllic, it also has significant implications for Proxima B's climate and its potential to support life. How would humans adapt? Would our biological rhythms need to change? Would we eat multiple times per day? Would our sleep patterns be affected? The patterns of life on Proxima B could be both remarkably similar to and strikingly different from those on Earth. It's a cosmic puzzle, one hidden behind a mystery that challenges our understanding of what makes a planet suitable for life. So, how can we gather accurate and reliable information about a planet we have yet to visit? This is where the James Webb Space Telescope comes into play. Like a colossal Swiss Army knife, a sharper instrument for scientific investigation than just a telescope, it functions as a powerful research facility in the void of space. With its innovative instruments, astronomers can not only observe distant planets but study them through an array of scientific tools so advanced, they make even the most sophisticated earthly laboratories look simple. Using advanced spectrographs, the Webb telescope can examine the reflected or emitted light from these remote planets. Each element or molecule in a planet's atmosphere interacts with light in various ways and wavelengths. By focusing on these patterns, researchers can conduct a remote biopsy of celestial bodies, revealing crucial information about their atmospheric pressure, composition, and the potential presence of life-sustaining compounds such as water, carbon-based molecules, and even oxygen. Space science is not just a matter of observation, it's space forensics. Researchers don't wait idly for clues, they actively search for them, analyzing the atoms and molecules that form these distant worlds. The Webb telescope is not just a passive observer, it's an exceptional research lab, a specialist, and an extensive analyst, all rolled into one. It allows us to test our hypotheses about distant worlds, offering concrete data that can either confirm or challenge our theories. And just when we believed we had discovered all the mysteries of this cosmic exploration, something unexpected happened. Researchers using the James Webb Space Telescope picked up an amazing signal. A subtle, rhythmic fluctuation in infrared light coming from the vicinity of Proxima B. At first, it appeared to be background noise, perhaps the result of stellar flares from its red dwarf star, Proxima Centauri, known for its volatility. But as scientists analyzed the data further, the pattern remained consistent, repeating, and unlike anything previously observed from that region. Whispers began to circulate within the astrophysics community. Could this be a sign of an atmosphere? Could it be a reflection off an oceanic surface, or something even more profound, technosignatures, possible evidence of artificial structures or communications? Caution prevailed, as it always does in science. The signal needed confirmation, peer review, cross-validation. Yet behind every skeptical remark lay a spark of curiosity, an unspoken question echoing across labs, telescopes, and observatories. What if? New observation windows were scheduled. The telescope's focus narrowed. With every second, Proxima B became not just a dot in the sky, but a possible mirror of Earth, or even a message, intentional or accidental, spanning across light years. The public remained unaware. For now, it was too early to speculate. But in private circles, late-night video calls and encrypted messages passed between researchers, theorizing about civilizations, biosignatures, the Drake equation, and the philosophical implications of not being alone. If this signal turned out to be natural, it would still be monumental, proof that Proxima B harbored dynamic, possibly habitable conditions. But if it wasn't, if the patterns suggested design, even in the faintest way, it would upend everything we thought we knew about life's uniqueness. So, the work continued. The James Webb Space Telescope, drifting in the cold silence of Lagrange Point 2, became the instrument through which humanity held its breath. One signal. One planet. One chance at the greatest discovery in history. And as scientists stared at their monitors, parsing data with trembling fingers, somewhere in the black velvet of space, Proxima B remained silent. Or perhaps, just quiet enough to make us listen harder. From Proxima B, a signal so intricate and unusual emerged that it sparked excitement and debate among scientists worldwide, and across social media. This signal was dubbed a possible technology signature, an electromagnetic emission so strange and complex that it raised the possibility of cutting-edge technological civilizations. For a brief time, the collective heartbeat of humanity seemed to pause in awe. Could this be the breakthrough discovery proving that we are not alone in the universe? Yet, as quickly as the signal appeared, it disappeared, leaving behind a profound silence and numerous unanswered questions. Was this just a cosmic fluke? An oddity of nature? Or could it be something more thoughtful? Perhaps a coded message or a signal from intelligence on other planets. This solitary signal has left a cloud of mystery hanging over Proxima B, igniting fierce debates and theories about its origin. Was it a fleeting anomaly, or could it be part of a larger narrative, one more intricate than we can even imagine? But hold on, the story doesn't end here. The search for answers continues, and it is no longer just ordinary scientists, but Harvard researchers, who are pushing the boundaries of our understanding. They are transforming the James Webb Space Telescope into a kind of cosmic night vision device, searching for artificial light sources in both the dark and lit areas of distant worlds. The possibilities are staggering. Imagine detecting the glow of cities on far-off planets, their lights cutting through the darkness like beacons of advanced civilizations. This is not only about the search for life. It's about discovering signs of intelligent beings shaping their environments in ways we might never have considered. As we dig deeper into the vast reaches of space, the search for alien life takes on new dimensions. This search, fueled by the rapid development of technology and a deep curiosity about our place in the cosmos, drives us to explore beyond Proxima B and into the distant corners of the universe. Instruments like the James Webb Space Telescope, alongside ground-based observatories, provide unprecedented insight into exoplanets, opening up new ways to learn about life and to understand the potential habitability of these distant worlds. Among the most intriguing areas of exploration is the hunt for chemical biosignatures, markers in a planet's atmosphere that could point to biological activity. This could include gases like methane or carbon dioxide, which, under the right circumstances, may suggest the presence of life. With the capabilities of the James Webb Space Telescope, scientists can now examine these chemical signatures with incredible precision. By studying the starlight that filters through an exoplanet's atmosphere, astronomers can identify key molecules, water vapor, oxygen, and ozone, that could point to conditions suitable for life. In addition, the study of a planet's environmental conditions is essential. Models based on Webb's data help predict whether a planet's temperature could allow for liquid water, which is essential for life as we know it. Planets in the habitable zone of their stars are of particular interest since they may have the right conditions for stable liquid water to exist. The search also extends to moons orbiting these exoplanets, some of which may contain oceans beneath their icy crusts, much like Europa and Enceladus in our own solar system. Beyond biosignatures, the concept of technosignatures is gaining momentum. These are potential signs of extraterrestrial technology, whether it's massive energy-utilizing structures such as Dyson spheres, or strange radio transmissions. As we refine our observational techniques and build greater global collaborations, the search for technosignatures could provide the long-sought evidence of advanced alien civilizations. In this grand endeavor, cooperation plays a vital role. Collaborations between space agencies, private research organizations, and companies are enhancing our collective ability to explore space. As we pursue missions to Mars and other celestial bodies, nations are pooling resources and expertise to reach new heights. Public engagement is also essential to keeping the excitement alive, inspiring the next generation of engineers and scientists to carry on the search for life in the universe. The investigation of exoplanets is a dynamic and rapidly evolving field. With every advancement, we edge closer to answering humanity's most profound questions regarding our role in the universe. As we continue to explore the stars, the possibility of discovering new forms of life, and gaining a deeper comprehension of existence in the vast universe, remains an exhilarating and boundless journey. This quest for knowledge is more than just an intellectual pursuit. It's a testament to humanity's curiosity and our desire to connect with the cosmos in a meaningful way. With each new discovery, we question the very concepts of life, intelligence, and what it means to exist within such an expansive universe. Whether it's through the detection of chemical signatures in distant atmospheres, or the possibility of observing technologies that are alien to us, the search for extraterrestrial life goes on. And in doing so, it piques our imagination. The implications of finding life beyond Earth would not only redefine our knowledge of biology, but would also reshape how we view our place in the grand tapestry of existence. Such a discovery would ripple through every corner of human life, science, philosophy, religion, and even the way we view one another. For centuries, we have looked up at the stars and wondered if we are alone. A confirmed sign of extraterrestrial intelligence would answer that question definitively and forever alter the human story. Our technologies are evolving faster than ever. Artificial intelligence, machine learning, and data-driven simulations now play a crucial role in processing the staggering amounts of information gathered from telescopes and satellites. These tools help sift through cosmic noise, searching for patterns, whispers among the stars that might signal life. Yet, for all our scientific might, there's still something deeply emotional about this search. It's not just data points and graphs, it's hope. The hope that somewhere, across the light years, someone else is also looking skyward, wondering if they are alone. What would we say if we made contact? How would we communicate? Would we even understand their language, their logic, their way of life? These questions don't have easy answers. But they remind us that the search is as much about understanding ourselves as it is about discovering others. The more we explore, the more we realize how rare and fragile our own planet is, a shimmering blue oasis in an endless cosmic desert. Perhaps that's the most powerful outcome of the search for alien life. It teaches us to cherish what we have, to protect Earth not just as our home, but as the only known cradle of life. And still, we reach outward. With every mission launched, every spectrum analyzed, every signal studied, we take one more step into the unknown. Whether we find microbial life beneath the icy crust of a distant moon, or glimpse the glow of an alien city on a faraway world, we move closer to a truth that has eluded us for millennia. The universe is vast. Its silence, profound. But somewhere within that silence, there may be an answer.